then we're going to talk about some log and exponential stuff.
Oh man, how did you get
Hey, you guys, everyone, AP credit weighted, like a C is the same weight as an honors B. Do you guys know that? Okay, I don't know if you guys know that. Like, if you get a C in an AP course, that's the same as getting a B in an honors class, as far as weight. Yes? The other thing is, don't forget, wherever you're at with your grade, 5 weeks before the final, and then 5 weeks in the second semester, come every morning, that's 5 points on the final grade, not the final test. On the final grade, that's over half a letter grade. Does that make sense, you guys? So if you're in that low B range and you're like, should I really want to get any in this class? Well, like, stay there, like, work on stuff, and then, use that as points. And the goal is that for the final, then, if you've done all that practice, you should be able to rock out the final and then get the final points. Does that make sense, you guys?
When is it?
It's 5 weeks before the final. So it'll be starting, I don't know how many weeks we have after, but sometime either last week in December or all of January, or something like that. Okay? But I'll let you guys know about that. Any questions on that? So remember that moving forward. Okay, so let's talk about this case here. The x over x. Is that an exponential function? Kind of. But isn't it power rule too? Not exactly. You know what I'm saying? The problem with this, the power rule is x raised to a number. Exponentials is a number raised to a variable exponent. This is sort of both yet neither. You know what I'm saying? This doesn't fit either rule, so you can't use either rule. So there is no new rules. You've already learned all the new rules. You know what I'm saying? Like, you have all the rules in your thing. What we have to do here is change the way this looks. And maybe that'll help. You can't use any rules as is here. There's no rule to follow, because it's not power and it's not exponential. But what you can do is, let's try, since this isn't like in exponential form, let's see if we can change it into log form. So you guys definitely write this problem down as we do it. How do you change this into log form? Yeah, log, this goes in the basement, and then this goes here, equals the exponent. Does that make sense? So if you moved it back to the other form, it would be x raised to the x equals y. Transforming between exponential and log form. Any questions on that? No? We can do a change of base over here, and that would be log, or I'm going to change it to natural log, because that's the easiest one to take a derivative of. You know what I'm saying? It doesn't have that weird thing tagged on. So I'm going to do natural log of y over natural log of x equals x. Any questions on that? Doing a change of base just on this thing here. I'm going to change it to natural log base. And then if I multiply both sides by natural log of x, I'll be left with natural log of y equals x times natural log of x. Which, I don't know, maybe it helps or maybe it doesn't, but I can take the derivative. I know all of these rules. I could have done it here too, but I wanted to get it in this form. If I dx both sides, what do I get on the left side? Everyone, peepers up here. What's that? Yeah, the derivative natural log going outside in. The rule for natural log is 1 over u. So 1 over y times the derivative of what's inside. What's the derivative of y in terms of x? Y prime, or dy dx. Exactly. Equals, what rule am I following on this side? Overall, it's a product rule problem. So set it up like a product rule. Derivative of the first times the second plus the first times derivative of the second. And that would be, this would be 1 times natural log of x plus x times the derivative of natural log of x is 1 over x. Or 1 over u times u prime. What's that?
Repeat the last part.
The derivative of natural log of x is 1 over x times the derivative.
Wait, the one before that.
Product rule.
Oh, okay.
Product rule is the derivative of the first. This is a product rule problem. Derivative of the first, which is 1, times the second, plus the first times derivative of the second. Okay, good question. So then, what's x times 1 over x?
1.
Yeah, so then I get, this is natural log of x plus 1, and then if I multiply both sides by y, I get y times natural log of x plus 1. Does that make sense, you guys? So I actually have y prime by itself. I've solved for dy dx. Okay? And again, this was 1, and then I multiplied both sides by y. So then I get y prime by itself. Now, you could leave it here. If you want your derivative equation just in terms of the input x, what can I make this y at? What can I change this y into? Yeah, that's what I started with. Y was equal to x over x, x to the x. So you can say that y prime equals x to the x times natural log of x plus 1. And that's the derivative. Okay? You know, it took some work, but there is no rule for this. So I had to use some log rules to figure out, like, to simplify into something that I can take the derivative of using my rules from chapter 3. Okay? Now another thing you can do, and this is usually what I do, you know, just like you can, and you'll get the same thing, and I'll show you that you will get the same thing. Just like you can square root both sides and square both sides, you can also natural log both sides, or log any base both sides. Because if you have 2 equals 2, then the natural log of 2 would have to equal the natural log of 2. Does that make sense? It's like a legal operation. So you can do that here. And why you would do that specifically in this case, and maybe we haven't seen that before, is that when you natural log both sides, on the right you have natural log of x raised to the x. And the log, there's one log rule that says if you have the log of something raised to an exponent, you can bring it down. You remember that? So then this is the same as natural log of y equals x times natural log of x, and then bam, you can kick it, you know, from right here and do it that way. Does that make sense, you guys? Again, use this whole like natural logging both sides or converting. Either way, it's you'll get to the same thing. Whenever you need to break something up, or whenever you need to solve for something that's in an exponent, that's a tool that you should be thinking about using. You know, if you have your variable up here and you want to get it out, natural log both sides, and then just bring it down. And if I wanted to solve for x here, I can just divide both sides by natural log of x. Then I solved for it. Does that make sense, you guys? So that being said, as a group, let's try 19 together now. 19 was x raised to the natural log of x. Knowing that, try this problem in your group. Y equals x raised to the natural log of x exponent. You guys, once you get to this, there's 2 things you can do. You can product rule it, or this is the same as, you know, not natural log of x squared, bring it down. This is natural log of x, that quantity squared, and chain rule the 2. You know what I'm saying? 2 times this times 1 over x. Does that make sense? Either way, you'll get the same thing. And then on the left, and I'll do it that way, or otherwise you can just product rule this.
We did it. I know. Okay. Wow,
No, you don't. That was in the answer. I mean, this is it. The only thing you have, if you want to get rid of your y, some people like doing that. So we're just kind of multiplying all that out and then multiplying both sides by the y. Here's your derivative. If you want it in terms of x, just replace what y is equal to. That was, I think, just equal to x, ln of x. Maybe not in this order. I'd probably put the 2 in front. Something like that. All multiplied together. Okay?